Hey everybody, it's a soft-spoken scientist. In this video, we're going to solve molarity problems step by step, exactly the same way they appear on your general chemistry exams. I'll show all setup, all unit conversions, and explain every step so you can apply this method to any problem. Okay, let's get started. So, molarity tells us how many moles of solute are dissolved per liter of solution. Every molarity problem starts from this equation. So this M is molarity. All right? So let's do practice problem 1. What is the molarity of a solution made by dissolving 10 grams of NaCl, which is Na is sodium, Cl is chloride, in enough water to make 0.500 liters of solution? I'm given mass and volume, but molarity needs moles and liters. So we know our mass of NaCl is 10.0 grams because they told us that. And the volume is 0.500 liters. They told us that. Liters is volume, by the way. Okay. And then grams would be for mass. Step 2, convert grams to moles. I'm going to write molar mass of NaCl. So if I look at my periodic table, I could find it for Na, and I would find it for chloride. And when I look at them and I add the one for Na plus the one for chloride on a periodic table, I would get, 58.44 grams per mole. Your teacher will give you a periodic table, and you'll look for Na, that number in the square, and the one in chloride, and you add them up and you get 58.44. Now, I have moles, okay, is what I need next. So I have to get moles of NaCl. So I'm going to take 10 grams divided by 58.44 grams per mole. So guess what? The grams cancel out, and then I'm left with 0.171 moles. Now I have moles, which is what molarity requires. Now, step 3, plug into molarity formula. So I have M equals, and if we look back at our formula, you guys would see it's moles of solute over liters of solution. So I have 0.171 divided by 0.500. They gave us that. And when I solved that on my calculator, I got M equals 0.342. All right, so the final answer is 0.342 moles of NaCl. Always include units. Molarity is moles per liter. Practice problem number 2. How many moles of HCl are present in 0.250 liters of a 2.00 mHCl solution? If I want moles, I multiply molarity by volume. So here's the deal. You have molarity, moles, and then you have liter. Okay? You're going to multiply both sides by L. And guess what? You have moles equals M times L. Substitute the values. So for moles, I'm going to say I got 2 times 0.250. And when I plug that in my calculator, I calculate it, I get 0.500 moles. So the final answer is 0.500 moles of HCl. All right? These problems are usually one line once you recognize the setup. Okay, let's try this one. What volume of solution is required to contain 0.750 moles of KNO3 in a 1.50 m solution? We're going to rearrange the equation for volume. So we know it's molarity equals the moles divided by liters. I'm going to multiply both sides by liters because what I do on one side, I got to do to the other. And then I have L times M equals mole divided by M because I want to know how to find the volume, which is liters. All right? So that cancels out. And by doing that, I meant to put an M. So I have L equals moles over M. So I'm going to substitute the values. 0.750 all over 1.50. And when I do this, I'm going to get 0.500 liters. Rearranging the equation correctly is key on exams. Let's try this one, you guys. What is the molarity of a solution prepared by dissolving 25.0 grams of CaCl2 in enough water to make 0.270 liters of solution? Okay, first things first, you gotta write your molar mass of CaCl2. Okay, so I'll do this one with you guys using a periodic table. I'm just gonna use it on my other device just because it's easier that way. So calcium, if you look at your periodic table, it says 40.078, and then chloride, there's 2 of them, and if you want to know how much chloride is, each chloride is worth 35.45 grams. So that's roughly 70, and then this is roughly 40, which would be like 110, right? So CaCl2, its atomic mass, or molar mass I should say, is 110.98 grams per mole for CaCl2. So I'm going to take the 25 grams that they gave me in the problem, I'm going to divide it by the molar mass. And when I do that, I get 0.225 moles. Okay, and then when I did that, I'm going to plug into molarity equation. So the molarity would be 0.225 divided by 0.750. All right, so the 0.750 came from there, and the 0.225 came from that. All right, I think that's pretty straightforward. So I calculate it on my calculator, and I got 0.300. So the final answer is 0.300 M, and then you got CaCl2. Multi-step molarity problems are extremely common on exams. Let's try another one. If the volume of a solution is doubled while the number of moles of solute stays the same, what happens to the molarity? So here's the deal. Molarity is cut in half because molarity, and this is something you got to know and drill it into memory, molarity is inversely related to volume. And y'all saw that when I wrote the equation out. One was up there in the numerator on the other side, and the other one was in the denominator. It's inversely related to volume. Okay? More volume with the same solute means a more dilute solution. All right? Common exam mistakes is forgetting to convert grams to moles. Please don't do that. And don't use milliliters. Use liters. Plug the volume on top instead of on the bottom. Plugging the volume on top instead of bottom is a huge mistake, I mean. Don't ever do that. Put volume in the bottom, all right? And don't forget your units. Most molarity errors come from unit mistakes, not the chemistry. Well, that sums up this video. I hope that I was able to help you guys. Molarity problems always follow the same structure, so just, rearrange it and do what you got to do. If you guys really liked what I just did just now, please like and subscribe. Please comment what you're thinking below. Any suggestions on anything. And remember, STEM is for everybody, especially you. Good luck, you guys.